Okay. All right, so that's going to be that with exponents. All right, so just let me know. Oh, and just very quickly, we also have the quotient rule: b to the x divided by b to the y. Remember, in this case, you subtract the exponents. Okay, only with the same base you can do this. Okay, so if no one has questions, let me move on to the next thing: rational expressions. Okay. All right, so I'll give you like a rational expression and I'll tell you to simplify it as much as possible. So here would be an example question about rational expressions. So I'll just be like, simplify this. So x cubed minus x divided by x minus 1. So I'm going to tell you to simplify something like this. And just remember the definition of a rational expression. It's a polynomial divided by a polynomial. Okay, so that's what this is. Good. So remember the technique for simplifying rational expressions. You want to factor the numerator and denominator as much as possible, and then cancel out any common factors. All right, so let me just write that. So you factor numerator and denominator. Okay, good. So the numerator, you can factor that by GCF. You can pull an x out from both terms. So what does this become? X times x squared minus 1 divided by x minus 1. So hope everyone agrees with that. I pulled an x out up here in the numerator. But now look at this here in the parentheses. You have a difference of 2 squares in that parentheses. So you're going to want to go even further. This will be x times, and now this highlighted bit becomes x minus 1 times x plus 1 and divided by x minus 1. Okay, so this x squared minus 1 is a difference of 2 squares, so I can factor it as such. Good, now you can cancel. So I have a factor of x minus 1 present both in the numerator and denominator. So that will cancel. So you're just left with x times x plus 1. And that would be it. You can stop right here. All right, so basically this is the technique. You just factor numerator and denominator and then cancel common factors. That's it. All right, so we need to use our methods of factoring. All right, good. So any questions? Okay, good. All right, so the next thing we did with rational functions was rational equations. All right, so just a quick example about this. Rational equations. So I'm not going to go through the full thing, but a question you would see under rational equations would just be like this. I'll be like, solve 2x over x minus 2 equals 3 over x plus 2. Okay, and this is a rational equation because all the terms here in this equation are rational functions. Okay, good. So what you do here is you multiply both sides by the LCD of every fraction that's present in the equation. All right, good. So the LCD here. So the LCD, more times than not, you're just going to take the product of what's here. So the product is just going to be x minus 2 times x plus 2. That is the LCD, okay? That's the least common denominator. Now you multiply both sides by this. So you will get, multiply both sides by this LCD, you'll get this 2x times x plus 2 equals 3 times x minus 2. Okay? And now so now I will stop doing the work, but now you just solve this. Okay. And the answers to this will be the solutions to your original rational equation. All right. Very good. So that's really all you need to know about rational equations. So let's keep going. Okay, now let me talk about lines. linear equations in the XY plane, okay? So very quickly, we have this point slope form of a line. Okay, and it was given by this. It's y minus y1 is equal to m multiplied by x minus x1. Okay, and what is this used for? Use this when you want to find the equation of a line with slope m, that passes through the point x1 comma y1. Okay. So what you'll do is you're just going to plug in your information into this point slope form of a line. You're going to plug m, x1, and y1 into this, and you'll get your desired equation of the line. Okay, so I'll be like, find the equation of a line with slope 2 that passes through the points 1, 1. Just use this. All right. Not that bad. Okay, so I think that's cool. All right, next, quadratic formula. So let's just do this quickly. So quadratic formula. Okay, so first of all, it's used to solve equations like this. It's used to solve this guy, stuff like this. X squared, ax squared plus bx plus c equals 0. Okay, aka a quadratic equation. Okay, it's used to solve quadratic equations. And here's the formula. Okay, it's just x, the solutions are given by negative b plus or minus square root of b squared minus 4ac, whole thing divided by 2 times a. Okay, so this formula, it uses the coefficients of your quadratic, okay? All right, very cool. So just a very quick application. Solve x squared minus 4x plus 5 equals 0. Okay, so to use this formula, we need to identify a, b, and c. So a is the coefficient of the x squared term. So a is 1 here. B is the coefficient of the x term, which is negative 4. And c is the constant term, something without, that has no x variable with it. That's 5. Very cool. And I just plug in. So here we go. X is equal to, let me scroll up, negative b. So it's 4, positive 4, plus or minus square root. So we're going to have negative 4 quantity squared minus 4 times a, which is 1, times c, which is 5. And you're going to divide that by 2 times 1. Okay? Good. So now you keep going. Now, I remember when I was grading the homeworks and exams with the quadratic equation question, a lot of students simplified this expression incorrectly. So be very careful when you simplify this, okay? So just take your time. So you need to be careful when you simplify the expression under the square root, okay? In this case, it's going to be negative 4 squared is 16, and you do 16 minus 20, which is negative 4. So that's what's going to appear under the square root. It's going to be the square root of minus 4. All right, so just please take your time when you simplify this discriminant. Okay, that's what this expression is called. Okay, good. Now, we need to remember that when you take the square root of negative numbers, out will come I. Okay, so we need to remember complex numbers. So just quickly recall, square root of negative 4 is equal to the square root of negative 1 times the square root of 4. Okay, and we gave a name for this square root of -1, and that's I, and the square root of 4 is 2. Okay, but usually you write the number first, so this is 2I. Okay, good. So let's just keep going. So this is 4 plus or minus 2I divided by 2. Okay, now you can simplify this a little bit. You can factor a 2 out from the numerator. So this is 2 times 2 plus or minus I divided by 2. And now you can legally cancel out these 2's. Okay. Now you can legitimately cancel out the 2's. So here we go. The answer is 2 plus or minus I. These are your solutions. All right, so I'm telling you now that the quadratic equation you're going to solve on the final will have complex numbers as the roots. Okay, so you will have to use I. All right, and I did that just to combine a few aspects, a few topics into just one question. Okay. All right, so any questions? Okay, let's keep going. 6. All right, now domain of a function. All right, we're going to do 2 examples. We'll do a square root example and a rational function example. So first one, f of x equals the square root of 2 minus x. Okay, now when you have a square root function, we're not allowed to take the square root of negative numbers, at least in our pre-calculus setting. Okay, so we need to set the radicand, the expression underneath the square root, to be greater than or equal to 0. So you set 2 minus x to be greater than or equal to 0. Okay, and that's how we ensure that only the square root stays positive. Okay, and you solve this inequality. All right, so what happens here? So this is 2 is greater than or equal to x. Now you can just kind of just swap the order. So this is x is less than or equal to 2. Good, and now you're going to put this in interval notation. So it's going to be minus infinity to 2. Now there's a less than or equal sign, which means we can permit 2. 2 is allowed. So I put a square bracket to indicate that 2 is allowed. Okay. So that's the domain. All right, so I'm going to tell you to put your answer in interval notation. Okay. So please do so. All right, one more here. Okay, how about this guy? F of x is equal to 1 over x minus 7. Okay, so one of the big problems or no-nos in mathematics is to divide by 0. So the domain of this function, we need to see where division by 0 can occur and remove it from the domain. Okay, so basically you just set the denominator equal to 0. Set the denominator, in this case it's x minus 7 equal to 0, and exclude this from domain. Okay, so we see where division by 0 will occur and we remove it from the domain. So, this is just x minus 7 is 0, which has a solution of x equals 7. So now you want to put in interval notation the whole line except 7. So this is how you do it. You go to minus infinity to 7 with a parenthesis, union 7 to infinity. Okay, that's it. All right, so just notice where 7 is not included here. We have round brackets around both of these, which means 7 is not included in our set. All right, so any questions? Okay, good. So how about composition of functions? Okay, so how about here? So like I'll give you two functions and I'll tell you to compute the composition f of g of x. So let me say that f of x is equal to 3x plus 1, and g of x, another function, is equal to 4x plus 2. All right, and I would like for you to find f of g of x. Okay, so this is the composition. This is not multiplying f by g. It's not that, so please don't make that mistake. So essentially, you go to f, and wherever you see an x in f's formula, you plug g in for that. So this is the same as f of 4x plus 2, right? Because here's g of x, and it's going right there. So it's f of 4x plus 2. So this means, again, wherever I see an x in f's formula, I replace it with 4x plus 2. So it's 3x plus 1, so 3 times 4x plus 2 plus 1. Okay? So just please be careful when you do these questions, all right? And then you just simplify this if you'd like. You will get that this is 12x plus 7. Okay? So just please let me know if you have any questions about this. This is very fundamental, very important if you move on to Calculus 1. Okay? Okay, good, good. So I don't have an example for this, but there will be a question about the domain of composition of functions. Okay. I don't have an example prepared for this, but I've done many examples of these types of questions in previous lectures. So please just go and find those. Okay, maybe look at the exam 2 review. I think so. Yeah, try looking at the exam 2 review, which is present in one of the lecture notes. So just look at that, please. Okay. Okay. So I added this to my notes late, so I have it labeled as 8.5. So this would be piecewise functions. Okay, so a piecewise function, it looks like this. Here's an example of one of them. So I'm just making this off the top of my head. So f of x is equal to, so it could be like 2x if x is less than 1, or it could be x plus 2 if x is greater than or equal to 1. This is an example of a piecewise function. So it tells you if your input x is less than 1, you use this formula. If your input x is greater than or equal to 1, you use that formula. All right, so I'll ask you guys, evaluate f of 0 and f of 2. That's what I'll say in the question. Okay, let's do f of 0 first. Now, 0, the input here is 0, and 0 is less than 1. So I'm going to use 2x. I'm plugging 0 into 2x. So it's 2 times 0, which is 0. Okay? So I remember a lot of students having trouble with this one. So I hope everyone understands. I'm plugging it into 2x because the input is less than 1. 0 is less than 1. But on the other hand, f of 2, well, 2 is actually greater than or equal to 1, so I'm going to use this formula. I use x plus 2. All right, so this would be 2 plus 2, which is 4. All right, so just please let me know if this is confusing. I remember some students getting this wrong, and it will be on the test, okay? So please let me know. All right, let's keep going. So 9, transformations of functions. Okay, good. So let's say I have f of x is x squared, and I have that g of x is, x minus 7 quantity squared plus 2. Okay, and I'm going to ask you, how is the graph of g obtained from the graph of f? Okay, so g is obtained by shifting the graph of f of x. Okay, so it's what? Well, the minus 7 in the input here, the minus 7 happening to the x, that corresponds to a shift to the right. It's a horizontal shift to the right by 7. Okay, so shifting the graph of f of x to the right by 7 units. And okay, now this plus 2 on the outside of the function, that's going to correspond to a vertical shift up 2. To the right by 7 units and up by 2 units. Okay, so you're going to need to, I'm going to give you a formula, and you're going to need to tell me what those transformations are geometrically. Okay, what's the picture? So this minus 7 means to the right 7, and the plus 2 means up 2. Okay, so any questions? Okay, and just very quickly, one more. So if I have a function f of x and I want to compress horizontally by a factor of 1 over 7, then the function is, so here you need to multiply the input by the reciprocal of the scale factor. Okay, so the function would be f of 7x. Okay, so hopefully you remember, when it comes to compressing horizontally, you need to always take the reciprocal of your scale factor. Okay, so if you compress the graph of f by a factor of 1/7, the formula for that is f of 7x. All right, so just make note of the reciprocal going on. All righty, so any questions? We're moving along. All right, good. So here is one of my favorite topics of the semester. This was zeros of polynomials. So this was really nice. So this was like when we did the rational root theorem, polynomial long division, synthetic division, rational roots theorem, and all that. So here's how here's what you need to know for the test, pretty much. All right, so here's the fact. X minus k is a factor of a polynomial p of x if the division p of x divided by x minus k, so the division has remainder 0. Okay, so it's a quick test to see if something is a factor of a polynomial. Perform the division and just verify that the remainder is 0. So here's an example. This is really nice. Verify that x minus 1 is a factor of, yeah, so x cubed plus x squared plus x minus 3. Okay, so what you do is you can just use synthetic division to compute, just to see the remainder very quickly. So use synthetic division. Good. So you place the coefficients of your polynomial in this, like in a row here. So it's 1, 1, 1, minus 3. So 1, 1, 1, minus 3. Make this half box thingy, and you place positive 1 to the left of the box. Okay, so it's x minus 1, so you ought to put positive 1 here. Okay, so please remember that. Good, so what you do here is you bring this number down, 1, and now you multiply 1 by this number that's to the left, so it's 1 times 1, which is 1. Now you add this column, so you do 1 plus 1 is 2. Now multiply 2 by the number here, which is, so you do 2 times 1, which is 2. Add up the column, so 2 plus 1, 3. Do 3 times 1, put that here, which is 3. Add up this column, 0. And this last number here always is the remainder. So yes, it's a factor. Okay, good. So now, like, the next thing you would want to do is that you can factorize your polynomial using this. So the polynomial factors as, so p of x can now be rewritten into a factored form, x minus 1, and now you take your answer from the synthetic division. These are the coefficients, okay, of the other factor. So it's going to be x squared plus 2x plus 3. Okay, so I hope you guys see the connection. I got 1, 2, 3. That's going to be the coefficients of the other factor. 1, 2, 3. Good, and now what you'll do on the test is you can now find the zeros of p of x easily. Okay, so obviously x equals 1 is a 0, just from this factor here. And for this factor, use the quadratic formula. Okay. So that's what you'll do on the test. But on the exam, I'm going to present it in a very step-by-step procedure. So it's going to be very clear. All right, so any questions about this? I really like zipped through this fast, but yeah. Okay, so 11, we'll do a very quick word about logarithms. A quick word about logarithms. All right, good. So firstly, if I have log of x equals 11, I want you to put this in exponential form. So remember, when the logarithm has no subscript, it's understood to be base 10. So this is the same as 10 to the 11th equals x. Okay, so just be comfortable converting from logarithmic form to exponential form. Okay, and here's an example of doing so. Okay, good. All right, good. Now we have these nice properties of the logarithm. We have this product rule. So log of AB, this splits up into a sum. So the log of a product is the sum of logs. So it's log of A plus log of B. Okay. And this rule holds for any base logarithm. Okay, I'm just suppressing the subscript to make it easier. This rule will work for any base. Yeah, So yeah, so any base logarithm will work. Good. We have that rule, and we have the other one. We have the quotient rule, log of a over b. Well, this splits up as subtraction. So this is log of a minus log of b. Okay, so we have these really nice properties here. And just a very quick note, natural log of x, remember this, what this is defined to be. It's a logarithm with base e. So just be aware of that. Okay, ln of x is shorthand for log base e of x, where e is that Euler's number that we talked about some time ago. Okay, so that yeah. Yeah, so that's all I have about logarithms. You just need to, you're going to just use these properties on the test and you'll be fine. All right, good. So now let's go into some more recent stuff. Trigonometry. Okay, very cool. So, you know, trigonometry has to do with mostly right triangles. So let me just draw a right triangle very quickly. Okay, I'll call the legs A and B, hypotenuse is C. Let me call this angle up here alpha, and this angle down here theta. Right, so I got two angles. Oh, and then this is a right angle, of course. Okay, so I have this alpha angle, I have the right angle, and I have the theta angle. All right, firstly, we have the theorem of Pythagoras, Pythagorean theorem. That just states that a squared plus b squared equals c squared. Okay, so this is you know, one of the most famous theorems in math. Pythagorean theorem. So you use this to find a missing side of a right triangle. Okay, good. Now let's talk about opposite and adjacent sides. So firstly, with respect to theta, the opposite is what? Okay, so you go over to theta, and then you need to look at what side is opposite from theta, and that's going to be A. That's right here. Okay, so opposite is A, and what's adjacent? And adjacent's B. Good. So now we're going to do this. We're going to do the same thing now, but with respect to the other angle, with respect to alpha. So now our vantage point has changed, okay? So remember, whenever you're doing opposite and adjacent questions, I need to tell you with respect to what angle, okay? Because the answers will differ. So now if I change alpha to be our reference point, it changes. Opposite actually is B, okay? Because from alpha, opposite side, B. Good, and adjacent, so go up to alpha, adjacent will be right here, this side A. Excellent. So the reason why you want to list this out is because now it's very easy to find cosine and sine of these angles. So just very quickly, we'll do an exotic one. We'll do cosecant of theta. Okay, so now remember, cosecant is defined to be the reciprocal of sine. So this is 1 over sine of theta, okay? This is 1 over. Now, sine of theta is opposite over hypotenuse by definition. Sorry, yeah, so it's 1 over opposite over hypotenuse, but then 1 over opposite over hypotenuse is the same as hypotenuse over opposite. Okay, good. Now we can just fill in the information. All right, so we're doing this with respect to theta. So it's going to be hypotenuse, which is C, and opposite is A with respect to theta. So that's your answer. Cosecant of theta is C over A. Good. Let's do one more. How about cosine of alpha? Well, cosine is a little easier. Cosine by definition is adjacent over hypotenuse. But remember, the adjacent we're using is the one that is with respect to alpha. So you need to use this one right here. So adjacent is A, and hypotenuse is C. So cosine of alpha is A over C. And that'll do it. So you can expect a question just like this on the final. Good. One more. So just one more which is like a sine or cosine question. So how about this? How about sine of 240 degrees? Okay, so for these questions, you need to figure out which quadrant you're in. So if we're in 1/8, if we're doing 240 degrees, that's going to be in the third quadrant. It's going to be like somewhere over there. You need the reference angle. Good, so the reference angle is the angle it makes with the part of the x-axis that's closest to this angle. So you want to find this angle right here. That's the reference angle, and you can just do 240 minus 180 to get that. So it's 60. Right? Yeah, it is 60. Okay, so that's this angle right here. That's 60 degrees. So now, now we're in the third. Yeah, so that's that. Also, in quadrant 3, you need to see is sine positive or negative. So, use one of your phrases. All students take calculus. So, in the third quadrant, tangent is positive. So sine is negative. Sine is negative, okay? All right, so there we go. So you just do, so sine of 240 will be negative sine of the reference angle, negative sine of 60. Okay, so this minus sign is coming because sine is negative in the third quadrant. And now you just use your trig table. So the negative sign comes, and sine of 60 is the square root of 3 divided by 2. All right, so that's how you do these questions. When you have angles that are in the second, third, or fourth quadrant, you need to use reference angles like so. All right, so I hope that's cool. That's cool. Okay, good. It's good. All right, so now let's move into identities, trig identities. So we have this really famous and nice trig identity called the Pythagorean identity, Pythagorean identity. And it states this, sine squared of theta plus cosine squared of theta for all angles theta, this will equal 1. So it's a very beautiful identity. So now just note that this implies the following. This implies the following. This will imply that 1 minus sine squared theta is equal to cosine squared of theta. And that's just obtained by subtracting sine squared from both sides of this equation. Also implies the other one, 1 minus cosine squared of theta is equal to sine squared of theta. Okay, so these will be important too. So we have these. Good, all right, so here's a nice application. So here we go. So here's an example. Prove the following. Prove that secant of theta minus tangent of theta times sine of theta. You want to prove that this is equal to cosine of theta. Okay, so this is a really nice question. And this is a trig identity that I will ask you to prove. Good. So you always start with the left side. Start with left side. All right, good. So let me start with the left side. Now, secant of theta, by definition, is 1 over cosine of theta. So you always want to rewrite stuff in terms of their definitions. Here's the minus sign. tangent of theta, by definition, is sine of theta divided by cosine of theta. So that's the tangent times, and remember there's a sine of theta, there's a factor of sine of theta still there. All right, everyone good? So I'm just replacing secant and tangent with their actual definitions. Okay, good. So these are two fractions that already have a common denominator, so you can just subtract straight across. So this is equal to, so the denominator is cosine of theta, and the numerator, you multiply these two, it's 1 minus sine squared theta. Okay, so they already have a common denominator, so you can just subtract straight across. So it's 1 minus sine squared theta. And look at our Pythagorean identity consequences here. 1 minus sine squared theta, that's equal to cosine squared theta. So the numerator becomes cosine squared of theta. So this is by Pythagorean identity. Good. And now we have a power of 2 of cosine divided by a power of 1. So this just reduces down to just cosine of theta. That's what we wanted to prove. So that's a really nice question. That's a really nice question, and it incorporates a few different things that we did. Okay, so this question may or may not be on the final. But there's a good chance that the same question is on the final. All right, so let's make sure that we get it right. Okay, good. Good. So any questions about this? This was like a little involved. There are a lot of moving parts to this. You had to use the identity and so on, but just please let me know. Okay, good. All right, last thing about trig. So there's like a quick graphing thing. I'm going to give you the graph of a sine or cosine curve, and I just want you to tell me the formula. So if you have a times sine of bx plus capital D. Okay, now if you want to find b, here's the thing. So firstly, if you know the period is capital P, you can find B by using this formula. We know that the period is always equal to 2 pi divided by capital B. So for instance, if I give you a graph, you can read off the period from that graph. You can visually see the period. So you can find P, and the way you get B from P is by solving this equation. Solve this equation for B. All right? So that's really all I have to say about that. Okay, good. Now let's move on to very recent stuff, sequences. Okay, so very, very cool. All right, sequences. Okay, good. So I'm going to tell you to list the first 4 terms of a sequence and tell me if it's explicitly defined or defined recursively, just like on the homework. So here's an example. List first 4 terms of the sequence 2n plus 2. Okay. This is not really that bad. So the first term is given by plugging in n equals 1 into 2n plus 2. So you do 2 times 1 plus 2, which is 4. That's you get the first term. You plug in 1 for n. Good. A sub 2, very similarly, you plug in 2 for n. So it's 2 times 2 plus 2. So what's this? This is 6. So you just keep going with this. Plug in 3, 2 times 3 plus 2. This is 8, and then a sub 4. You plug in n equals 4, and this is 10, right? Yeah. Okay. Now this is explicitly defined. Okay. Reason being is because I have a formula here. I don't need to use previous terms or anything like that. I just plug into one formula. All right, so you'll have something like this. Okay, good. Now let's talk very quickly about arithmetic and geometric sequences. So let me give you guys a sequence. So I have 5, 10, 15, 20, 25, and so on forever. This is a blank sequence. So is this geometric or arithmetic? Well, you can just kind of look at the relationships between a term and its previous term. So first check for arithmetic, it's easier. So you look at the difference between consecutive terms. 25 minus 20 is 5. 20 minus 15 is 5. 15 minus 10 is 5, and 10 minus 5 is 5. They're all 5, the difference. So this tells you that this is an arithmetic sequence, okay? That's a definition of an arithmetic sequence. Now, if you know it's an arithmetic sequence, you better tell me what the common difference is, okay? So with common difference, what? Common difference, D. Well, that was just that number 5 that we got from all the subtractions. Okay, so that's 5. All right, so that's good. That's really all you need to know about this. Now let's do one more. Let's do a geometric. So 2, 8, 32, 128, and so on forever. Well, this is, well, divide a term by its previous term. 128 divided by 32 is actually 4. 32 divided by 8, also 4. 8 divided by 2, also 4. They're all 4. So this is definitely geometric with common ratio. And the common ratio is just going to be that number you got from all of the divisions. So it's 4. Okay. Any questions? So I'll just be asking you to identify.
Yeah, it's just because.
Can you also have non-arithmetic, non-geometric?
Yes, absolutely.
Mm.
You know, like this example from the homework.
What we could have done.
1, 2, 4. 9, 16, all the perfect squares. That's neither arithmetic nor geometric. So no, they do not need to be one or the other. No. Good. All right, guys, I'm on my last page here. We're just going to talk about series, and then we will be done. All right, so the last thing, series. So I'm really glad I was able to get these last 2 topics into a pre-calc course, sequences and series, because they're not always taught in a pre-calc course, but I think they're very important. So very glad that we had enough time to do that. Very cool. Okay, so here would be an example question. So I'll be like, write this guy, this summation, right? K equals 1 to 3 of K plus 2 in expanded form. And find the value. And find its value. Okay. So when I say expanded form, I mean just plug in your indices of summation. Plug in the numbers 1, 2, and 3 into this and sum it up. So this will be, you plug in 1. This is 1 plus 2. You add, plug in 2 now. This is 2 plus 2 plus, plug in 3. This is 3 plus 2. And I stop at 3 because that's my upper limit of summation. So once you hit this number 3, you're done. And remember, I'm plugging these numbers in for k. And I'm adding them. All right. So this is just, what's this, 3 plus 4 plus 5? Yeah, this is 3 plus 4 plus 5, and this is 12. So there's gonna be a question just like this. Write out the summation in its definition form, in its expanded form, and then just add the numbers. All right. So I just want you guys to show me that you know what this notation means. And that's why I ask you to put it in expanded form. Okay, good. Last thing. So the last thing will be a sum of a geometric sequence. So this is very important. That's why I'm going to put it on the final. Okay, so if a sub n is geometric with ratio r, then the sum of the first n terms is given by. So we have a really nice closed formula for the sum of the first n terms of a geometric sequence. And here's the formula. It's S sub n is the initial term a1 multiplied by 1 minus r to the nth divided by 1 minus r. So a really nice formula. So remember, this is for a geometric sequence, okay? The sum of the first n terms of a geometric sequence. All right, so let's just do an example. Find the sum of the first 5 terms of this guy. 1, 2, 4, 8, and so on. Okay, and I'm going to say that you necessarily have to use the formula. Okay, I don't want you to just list out the first 5 terms and add them yourself. I want you guys to demonstrate to me that you know how to use the formula. All right, so if you just add them together, that really won't be an acceptable answer. Okay, so what do we need for the formula? We need A1, R, and N. Okay, not bad. So here, A sub 1, the first term, is 1. So that's 1. Okay, what else? What's the ratio? Well, the ratio, you can just divide a term by its previous term and see what's up. So 8 divided by 4 is 2. 4 divided by 2 is 2. 2 divided by 1 is 2. So that's good evidence that the ratio is in fact 2. And what's n? N is just the sum of the first whatever terms you're finding. So in this case, it's 5. So there we go. We have everything we need to plug into our formula. So S sub 5, the sum of the first 5 terms. So it's A1 multiplied by 1 minus the ratio to the 5th power over 1 minus 2 divided by 1 minus 2. Okay. Yep. Good. So what is this? Yeah, so you just kind of work this out. You'll get negative 31 divided by negative 1. Okay. And this will just be positive 31.